Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com workshop, brought to you by TechStrong. My name is Cody J. Brown, and I will be moderating today's session. We've got an exciting presentation ahead of us, but before we begin, I have just a few housekeeping notes. Today's session is being recorded, so if you miss any or all of the discussion, it will be made available to rewatch. You will receive an email after the webinar concludes with a link to access the on-demand. We also want to hear from you throughout today's presentation, so please feel free to send in your questions at any time throughout the program by using the Q&A feature. We will try to address as many questions as you can send in, so please send your questions in early. Finally, at the end of today's webinar, we have a drawing for 4 $25 Amazon gift cards. Stick around to see if you are one of our 4 lucky winners. But let's go ahead and kick off our webinar. The topic today is Shifting QA Left, Emerging Trends in Code Quality and Security Automation. And I'm joined today by Sal Kimmick, Developer Advocate for Sonatype. Sal, thank you so much for being here with us today.
Excellent. All right, Cody, thank you so much. I will go ahead and take it away. As Cody said, we are going to be talking about shifting quality analysis left and some trends in code quality analysis as we shift more and more towards shifting left and towards automation in the way that we build. So you should be able to see my screen now as we go ahead and get started. If so, we're just going to jump in. Again, my name is Sal Kimmick. I'm a member of the developer relations team at Sonatype. My background was in machine learning, but primarily in security development spaces in the government. I care a lot about developing secure spaces, but doing it with open source at Sonatype. So today we're going to cover 5 main topics that really blend together. There is a lot to go over, but if you can hold out for the end of this session, you're going to have a much better understanding of what we're looking at for the modern software supply chain for 2021. We're going to start with modern development and what the definition of shifting left really means, the types of quality analysis and what the new wave of open source security looks like, what QA is and why it's a people problem today, and how we can use developer productivity to maybe get around some of the problems we're facing. Talk about cognitive engineering for your developer pipeline and how Sbombs and streamlining the global software supply chain is really the next step and how you can be integrated for that. So as we tell this story, we're going to keep talking about this software developer. When we're shifting left, a DevOps engineer or a full stack engineer is typically going to have 2 different types of pressure that they are negotiating when they are making decisions. So typically they're being asked to deliver products, right? We're here, we're building, we're producing lines of code. If I want to bring in a tool, bring in a solution, bring in a project, I want to make sure that I have a just-in-time solution. If it's helping me to solve a problem, I want to download, install, use it, and get rid of it if it doesn't help me solve my problem. And it needs to be self-service. I can't use a webinar. I need to be able to have it into the way that I'm already doing my work as I build. The second pressure here is this continuous shift left of responsibilities and authority to developers as decision makers. In this case, we're going to be talking about how the average developer who may not have any formal background in security research is now being asked to make decisions that have an immediate impact on security in architecture, given the way that our pipelines have been developed. And I think one major point in this is that shifting left is that typically you would have had the development of a product and a check a little bit later in that development process where you would see, is there a quality analysis? Is there someone in our enterprise who's going to be looking into this system? At this point right now, you have to make the decisions before you build the application about what components you want to build in. And that's pretty new. That's a change that we're seeing in the last 2 to 3 years. So how do we do this? When we want to see whether or not our applications are running well, there's a couple of different types of ways to do that. The 3 that I want to focus in on are dynamic or runtime analysis. This is really making sure, does my application run the way that I want to after I click execute? Second, there's sort of proprietary application testing. So this is typically referred to as SAST or box testing, where you're looking at your application services. Or there is static component analysis. So SCA is really what we're focusing on today because it's becoming one of the places where the biggest problems are. So this reliably allows us to detect and map known open source vulnerabilities in the dependencies of the code structure that we have. One quick note that I want to say on this is that SCA is not above and beyond or an exemption to SAST. You want to be doing it with that. But here's some clarifications to that point. If we're talking about SRE, if we're talking about site reliability engineering, any other form of testing, it might be a little bit expensive, but it isn't actually terrible to be doing or maybe necessary to be doing runtime analysis. That's fine. But if you are doing cybersecurity, then most of these bad actors are actually looking for those exec files. So if you're doing runtime analysis of security, you've definitely done it too late. It's just not possible. Additionally, most of our modern open source injections, these aren't sort of like SAST applicable sort of analyses. We really need to be looking at sort of a deep injection of what are the things that I'm pulling in from open source and what are they pulling in as well. So while that's good, it's not great for some of the major issues we see. You really want to be using a good combination of static component analysis tools because they're going to let us see a full account of the open source in use, and particularly, more important than anything else, this is going to allow us to see when new vulnerabilities have become discovered, because these things pop up all the time. These are real people on the other side of these attacks, and they are looking for new ways to inject into our systems. So when we're talking about static composition analysis, this is scraping through our code base before we do the execution. There are a variety of ways to do that, from shallow to deep analysis. I do want to state for this particular part of the talk, a lot of this research was originally done by Stephen McGill and his research team. It's very interesting. There's a lot of in-depth knowledge here, but I want to really pull out some of the core nuggets from what other major industry leaders have done. So if we're talking about shallow analysis here, really the standard example is grep, right? Giving me a graph representation of my code and allowing me to see patterns within that. More advanced, deeper analysis would be something in the example of graph analysis, which may allow you to see something which is much more procedural in the code. Those take more time. It takes more time to find those as you're scraping through it. Oh, deep analysis, my apologies. There is going to be one typo here. This takes minutes. This can sort of, typically when I'm running my deep analysis, sometimes it doubles or triples the amount of time it takes to, for example, do my build for a given project. So if you're doing shallow analyses, you're going to be able to see things like simple API misuse, depreciated APIs, leaked authority tokens, authentication tokens. On the deep analysis side, you get things that are much more relevant, and you're really getting towards that more capital V verification of security, much closer when you're looking at what are memory errors, thread safety problems, performance issues. You can really get to both security and performance issues that are interesting, valuable, and are much more important to catch before you go into runtime, right? This is why SCA is becoming more powerful with more automation as we move into this sort of next decade of sort of pipeline delivery. So in this section of the talk, I'm going to cover our sort of shallow to deep analysis. Again, this is things that take a few seconds to deliver, whereas a deep analysis, this would be a few minutes to deliver on average. So beginning with grep, the example that we just gave, we can now move on to sort of PMD, which was created by Google. Now, this is a really basic way of, again, looking at sort of a graph distribution, a sort of tree index of your syntax, and then finding patterns within those. It makes it really easy to do things like pattern matching on sort of strings, for example, right? These are things that it's useful if you can automate these. You can also have an intern do them, let's be honest here. But this really on that side is using automation to just sort of linter out some of those issues. But as we get a little bit further, it gets more interesting. So that's valuable, but you can't catch everything. And now, so Facebook created a Infer, which is actually going through, again, we're talking about a little bit more time to scrape through. It does take more time. This is more deep processing, but we're able to now find procedural issues where there's multiple calling spots in the code, particularly being able here to identify when we're going to have a major issue. So I think this is great and interesting because this is really the breaking point in the evolution of SCA, where we went from something that was sort of good and, you know, sort of hit the limit of what sort of human hours are also able to do. But now we're really looking at what is scalable. So Infer is really getting us to another level and using SCAs to really be able to look broadly at the quality of a large repository. Now, my last example is going to be Uber's Nullaway, which I think is a really interesting alternative, because while I've given you all of these, almost none of these stand up to the quality analysis accuracy of doing a traditional human-based code review. And so one of these really excellent deep analysis processes is actually using Uber's Nullaway, which, while it does automated highlighting, it actually requires a manual intervention from developers to annotate it, which I think is an interesting way of having a human in the loop as we're getting closer to automation, to ensure that as we're working on these hard edge cases, we get true confidence that isn't just computed, but is actually verified. And if we have large global communities working in this way, that's a great way to start solving these problems. So that's a little bit of the spectrum for modern automated quality testing. And again, let's go back to our modern developer and all of the pressures that they are currently experiencing. Now, what context do they live in when they're building out an application, whether or not they really have an understanding of security? They're typically going to be engaging in the open source software supply chain. Typically, you're going to be pooling in projects from open source sort of libraries. These can come from, you know, Maven Central, PyPy or PyPI for Python packages. There's so many repositories where you pull in the package that is valuable for that application, that aspect, that component of your application. You build this through into your source code, you containerize it, and if you're doing everything well, you're able to scale this by using infrastructure as code. Now, a few things about this developer and the team that they live within. I know some things about them statistically. So as they develop their application, over 90% of the components that they're going to use in 2020 to 2021 were going to be coming from an open source project, meaning that my team of developers is now really surrounded by an invisible layer of developers who are sometimes on the same teams over in other countries or distributed, or individual contributors to open source, allowing for a lot of different information and progress to come in, but also sometimes some bad actors. Now, second, it's allowing our developers to begin working much, much faster. This means that we're on the, working in open source. I can't explain how inspiring it is to see the amount of human progress and the evolution that we can make with intellectual property when we share it. So we are getting over 200 times faster in the frequency of our deployments, creating new progress that's more efficient every time. And one final note on this, that's to say that in every single ecosystem, we are seeing this explode. Open source is what people are relying on because it is effective and it is emblematic of human progress. If you want to have the cutting edge, you have to use open source. That is true in every single ecosystem. I think that's beautiful, but it's also a little bit scary because there's a very, very, very small percentage of those people who are engaging in this software explosion who have bad intentions, and some of them also create bots. Now, this is why we have a new generation of software supply chain attacks. So when I tell you that there's a 615% increase in software supply chain attacks year over year, yes, that is true. Yes, that's a little bit scary. But when you look at that in the context of human process, this is absolutely a problem that we can get around, but we have to be smart about it. And that is why I'm giving this talk today. So if I am that developer and I'm pulling in a project from any of these major ecosystems, I'm going to be choosing on average the most popular components, the most likely to be maintained, the most likely libraries, the most likely to be maintained. They're also the most likely in all cases to be attacked. So not only am I choosing something which is most likely to be maintained, but it's having to be maintained, and those releases are having to be sort of increased in velocity because they're being attacked. So yes, it is still best practice to choose the recent versions of the most popular packages in your given ecosystems. But know that that's where the battle is really being fought for cybersecurity right now. So I've told you a little bit about the general map of this. What does this look like in practice when it's inside of my code? I'm going to give you the three biggest examples from 2021 as we're coming into the end of it. We're going to start with typo squatting. So I like typo squatting because it's such an interesting way of attacking at that level of sort of an individual developer, because all that it's doing is making the assumption that some percentage of developers will mistype when they want to import a package. And for this example, for anyone using a Python package, matplotlib, that provides you scatter plots, it's used by almost every data scientist, every analyst. They target it because it gets downloaded by millions of developers in a week or in a month. Now, if 1% or 2% of those users, of those that downloaded it, misspelled with a double P or a double L, in this case, a typo squatting attack would actually then import not matplotlib, but a crypto mining sort of process where it would then start crypto mining on your own computer and then taking that and giving that back to the bad agent. So I think this is just one very simple example of people not thinking about cybersecurity being in things as sort of low level or disconnected from security as your scatter plots. And that is exactly why these attacks are working. So we can get in and we can fix them and we can make people aware of them, but you really need to start being careful. The second sort of most common attack that we saw in 2021 was dependency and namespace confusion. So this is when a bad actor is going to publish a malicious package using the exact same name or a newer semantic version of a common package. So what does this look like in practice? So in February of 2021, an ethical hacker, so a white hat hacker, was going through and demonstrating that this namespace confusion could successfully be done on some of the major packages within NPM. Unfortunately, while they were disclosing this and doing this in an ethical manner, between the time of them disclosing that and the sort of fixes in making sure that this could be addressed, over 10,000 dependency confusion copycats actually came in and infiltrated on those exact namespaces. So I think that this example is important because it demonstrates when we're talking about typo squatting, we're targeting now individual developers. We're not targeting enterprises. We can hit the enterprises through individual developers. When we're looking at namespace confusion here, it's fascinating because at that point, they're using that individual developer to have a blast radius of thousands and thousands of projects. That's what they want. So a third example is malicious code injection. This might be something that you would have considered if you were thinking about open source cybersecurity, stealing the credentials, acting as if you are the real maintainer for an open source project while you're injecting malicious code, releasing new versions to a public repository that have malicious code, contributing malicious pull requests, or tampering with open source tools that would then inject that downstream into the application. The important note about malicious code injections is, again, right, when we were talking about runtime, we don't want to be finding these after we have run the execution file. These things can sit and lay dormant until they want to have them run live. They just want to be sitting in the background waiting for their time to be active. The best example of this, I think, so far, that is at least the most common right now, is the malicious code injection on SolarWinds in December of 2020, which actually Trojanized downstream to almost 20,000 customers, including national security and NASA. I mean, this was major, and there are dozens of attacks like this in a year. So a quick step back, because I know that when I give that part of the talk, I can scare people. But I do want to assure you that this is something that we're working on, and there's a couple of ways which we can really improve the processes that we have on our own developer teams, but sort of globally. And that's what the rest of this talk is going to be about. So let's take a deep breath, and we are not going to be overwhelmed by the level of cybersecurity attacks. We're going to talk about a engineer and really what they focus on in their day-to-day. So whether you are sort of working on SRE or on more of the cybersecurity side, typically we have service level agreements. So if we have a major security event or a major reliability outage, something like that, those are going to be noted in our service level agreements. And those are usually defined by our mean time to acknowledge, how soon did we know that it was an issue, and our mean time to resolve, which is much more important. How long did it take us to fix this problem? And then you can do some more discussion about how many people were impacted, et cetera, et cetera. But this really is about the severity of the business impact, and that those are entirely correlated. So in this case, this should be reactive. There's really two approaches to this. Traditionally, we had a reactive approach in which we would only know after damage was already done. Again, this is what bad actors want to occur. That is the situation which is ideal for them, is that they have a sleeper file sitting in your system and that they're able to attack at any time. Or you can use SCA and you can start to take a more proactive sort of look at this. So the reactive way of this is really unfortunate. So you find out that you have been breached, that you have a major vulnerability. Either you find this out through sort of secondary sort of proxy behavior that is abnormal for your application, or you can actually find it through doing one of these sort of analytics. But if it has already caught you inside of runtime, this is where you're at. You're reactive. So was it a known or known issue? Is there a way for us to resolve it quickly? What's the criticality analysis after we've shut it down? What's the severity analysis? How many people were, how big is the blast radius of this? And how many people do we need to notify? That's a terrible place to be in, but we have to have our processes in place for that. Because right now, there's a major issue with understanding, in my view, that we are in this situation of having to do these defensive or reactive or post hoc engagements for cybersecurity because we haven't recognized how much of a people problem it really is when we're trying to solve these kind of issues. So this developer is going to be putting together an application that's created of many, many, many different components. And as they can choose each one of those components, each one of those submodules, those will have versions that they need to choose from. So it's a really, really complex problem to get right if I am genuinely just using on even a team of hard thinking professionals to decide how to do dependency management right. Now, I can tell you this for a fact because as of 2021, when we looked at what the most secure versions of any given package would be, and the version that teams most likely chose on average, 64% were not choosing the most optimal version of a given package. Only 31% were. Now, if we can shift that, that is hundreds of thousands of man hours, making sure that we are not wasting time doing 2 or 3 or 4 times refactoring to get to the right version. Every time you're at the wrong version, you are at a vulnerability level that is higher than you need to be. So as we're trying to shift the way that we manage our supply chain security and maturity, we want to move way towards the sort of right-hand side in this case, towards monitoring and measuring. But we want to do that in a way that's really, really embedded in the way that we already work and engage on these problems. So here are some of the sort of high-level ways that as developers, any senior developer would look at this list and say, yes, this is exactly how we make decisions. This is the overall gestalts. If we can sort of mechanize these, and we do mechanize these in some products, great. But it's still hard to get this genuinely correct because of the compositionality problem between that macro architectural decision of, yes, I know that this package connects to this package, this authorization, et cetera. That all works. But do those all create secondary security concerns if their dependencies are being updated? Now, That may have sounded a little bit confusing, but this is all around the idea that this is a bunch of really hard and invisible labor. So let's talk about all of that was around why security is so hard to do, but why shifting over using automation and using it embedded inside of our development pipelines might solve that problem. So here's our trusty developer again, but this time they're going to use SCA and they are not going to have a protocol to report out to stakeholders that anything went wrong. Why? Because they're going to take a couple of minutes to go through all of their code base before they go into a runtime environment. And with SCA, we're in a couple of interesting things. So using, in this case, a product called Lift, which I really enjoy using. You can use this for free forever on any open source repository. What this does is allow me to go through and passively scan as I am going through my code and identify through deep code analysis anything major that might be coming up for me, whether it's stylistic or security. And this goes over a multitude of languages. So even when I have a combination of languages, this is really helpful. It brings it all into one place. But instead of giving me a bunch of noise to signal, which I can't handle, right? I need to be able to know what is my problem and how do I solve it? Because I only have 2 weeks in a sprint and I have 8 hours in a day, right? I can look on Stack Overflow forever, or I can do what Lyft allows you to do, which identifies where the bug or the issue is directly in that code, and then it reports it to you as a PR. So it does it inside of whatever your own flow and process is. It doesn't have to be GitHub. You can use GitLab. Bitbucket we are also providing for. So whatever your natural system is, wherever you would be reporting these issues as a person, will come in and flag it as a bot, but then you can come as a person and say, look, do I want to engage with this in my code base? Is this worth, again, sort of that approach that Uber was taking of, can we identify through automation what the problem is and then use a human on top to make sure that we've got confidence that we're spending developer time wisely. Now, when we put them in a pull request, we found something really great, right? So it is not worth it to run an analysis if you're never going to use the outcome. And so many, particularly security tools, you run an analysis just to see your entire screen bleed red, and then you run away because you don't know how to solve it. But we have found that by using it this way, that you are over 70 times more likely to actually have a PR go into a merged solution when you do it in this way. So it saves a ton of cognitive load. It saves a ton of research time because it's embedded in the tool. And then I think most importantly, by getting rid of all of that extra noise, both in the way that you're actually getting alerted and the way that you hold on to those alerts and process them as a team, it makes it a lot easier for you to eliminate likely false positives and then focus just on the urgent issues. Again, there is nothing quite as intensive as sort of holding the pager for security. When I have a security vulnerability or a security breach, I have less than 12 hours for sure to get that solved. So this is what's really most important about taking a truly proactive approach to what you're doing. We're going to come back to Lyft a little bit and about why it's so valuable and how it really makes your entire process improved. But I wanted to step into looking forward into 2022 and how some of the way that we're reasoning about the open source supply chain and providing solutions for that is really facilitated and looking into the way that we want to use Sbombs or the software bill of materials to streamline the global supply chain moving forward. So most of us or all of us have heard by now about Sbombs from the executive order and from many major federal orders around the world now, looking at finding what do we want to use as the real metadata to be able to understand how our software is interconnected. So an SBOM is a complete formally structured list of components, libraries, modules to build and compile a given piece of software. So I really like Sbombs because I'm a Virgo, and in a very simple sense, Sbombs are not complicated. They're just lists, and they are different types of lists depending on what it is that you really want to be focusing on. So 3 of the really main types, and the federal mandate really does allow you to use any of these, but you can do SWID tags. So those are standardized XML format. So these are sort of installation, post-install. It really goes through the points of the supply chain for your application. But the two that I really want to compare and contrast here are the XPDX and the Cyclone DX. So SPDX was from the Linux Foundation. A lot of people use it. It captures the provenance, so where it came from, and also the licensing and security. This is to say that both like XPDX and Cyclone DX do cover security, but really in different ways. And this is what's so important. This is not an exclusive option. I would definitely recommend using both because SPDX, having an SBOM with XPDX within it, allows you to really track and trace the licensing, which is incredibly important. You know, we live in a GDPR compliant universe, but really as that becomes more complex and as the trees of dependencies become deeper, you really need to have that clearly. Now, it's these trees of dependencies that are why we use Cyclone DX specifically for security, because we are really, really interested in getting the metadata that allows us to see when I'm pulling in a package that is also pulling in a package that could even potentially be pulling in a package at any point along that chain. We could be introducing one of these new wave vulnerabilities. You can't really capture that level of information from SPDX. You can only get that from Cyclone DX. But in using Cyclone DX, we've been able to really evolve and secure a new quantitative metric when you're trying to be that average developer looking out and choosing a package, trying to find a way to help them make that right decision fast. So there's a couple of ways to already sort of go out and choose the right open source package, libraries.io from SourceRank or OpenSF criticality score. Both of those do rely to varying degrees on some ideas of how often is it updated, how active is the community, really sort of like what can we see at the repository level? Is it active? Is it going to be maintained? There are some differences there, but the difference between those and MTTU, which is the mean time to update, is that those are really giving us a general idea, but this is giving us an actual quantitative number of whether or not me introducing a new package or a new update to a package, a new package is going to be the right option, right? So that really difficult choice. So this tells us how quickly an open source project that's not maintained by me, right? These invisible developers on external teams that are open source, how that project is maintained. So if it's a low MTTU, that then means that those maintainers of those projects that I depend on are continuously updating that project to account for any runtime or security vulnerabilities. So it's more secure, it's more likely to be a stable and long-term option for my architecture. So my architecture can be more secure. There really hasn't been anything up to date so far that allows us to get that quantitatively. I have a whole talk on being able to calculate the MTTU and really understand it. But as one final note here, I just want to say that we're calculating when a when a package has a couple of different dependencies that need updated, those get updated and it updates those so that it is sort of to the best practice of security or stylistic practice. That's our MTTU, but it is directly and it is strongly correlated to that MTTR, so mean time to remediation. That's super important because instead of having that reactive mean time to remediation, what you could have instead is a team that's doing SCA well, that's looking at the MTTU and is finding components with low MTTU scores. So you never, ever, ever have to go into your response. You shouldn't have to be reactive. This is what I'm saying. This is what I'm so passionate about. So please. Another reason why this is so important is that when we're looking at that behavior of when maintainers of open source projects are making those updates, we're actually seeing what is basically an immune system of both the evolution of new features, but the protection of that entire project. And that MTTU, when we analyze different open source projects, particularly in this case in Maven Central, see there's your Java, those are updating. So your open source component is delivering a new version now almost exponentially faster than it was a year ago. So a year ago, or a decade ago, it was over a year. A month ago, we were looking at a little less than a month for a new version update. I don't know how many components you might have in your microservices, but when we're looking at maybe in a year from now, every single sprint, you need to update every single component because it has a new version potentially. That's the reality we're looking at, and that's why you need automation. So right, we're back to this developer who's sort of in this continuously shifted left space. The open source cybersecurity attacks are like nothing we've ever seen. And if these bad actors are doing their jobs well in their minds, they are going to continue to deliver to us security attacks like we have never seen. And that's really interesting, but it's worth being aware of. If you're interested in sort of getting ahead of that, then I really suggest that you download Lift and give it a try on any of your open source repositories. I use it on all of my open source projects and on a couple that I like to reach out to and sort of help to maintain as a contributor. A few examples. So Sonatype Lift, we installed this about 2 weeks ago on a bunch of open source projects that are in the CNCF sandbox. Here they are. If you're a Kubernetes developer, then you would be familiar with one or all of these. But if you install Lift, you get dozens upon dozens of pre-configured analyzers that are top of class across languages. And so this allows you to get performance, reliability, runtime, style issues, security. It's everything. And that's what's really so useful for me. It's all in one place. And SCA means that it is just run and I come back and I've got some pull requests that I can either choose to move forward with, delegate, or ignore. It's great for my process. It's built for developers with peer code review. It works in your pull workflow. And what's super important here are these last two notes. It's one-click installation. It's free forever. It's on your repo until you want to take it off, but you don't want to take it off because every time there is another PR, it's going to run an SCA. And before that gets put into your code base, you're going to know whether or not it's a lemon or not, even that addition, that single PR. So it saves you so much time, so much energy, so much cognitive load to work in this way while you're solving a huge problem, vulnerabilities. Don't even enter them into your system. This is the only way to really do that well. And for me, what this means is that if you've got Lift installed and you're working in this way, you're not going to have backlog headaches. As I said, you can have backlogs for other processes. If you have security backlogs, you're not good at your job, right? We got less than 12 hours to deal with vulnerabilities if we're doing this well. You want to be alerted and you want to solve it. If you've got this tool, you'll never have a backlog. You will be alerted and you will solve it. And that's really why I was highlighting using a tool like this, using SCA. There's no other way to really find out that there's new vulnerabilities, a new way to breach this version that we just found about 2-3 days ago as a global community. Really doing SCA this way is the only way to stay up to date in a reality where, everything is changing and we've got to look at this it's insane. I'm interested to see what 2030 in cybersecurity looks like. But for 2020, 2021, what we covered was modern development and what shifting left really means, and a little bit about why quality analysis and the new wave of open source security is becoming really important, and they're so super intertwined. Why it's such a people problem and developer productivity really needs to be considered if we're going to solve this well. It's not just that our tools need to be better signal to noise. They need to be super actionable when we provide the insights. Our cognitive engineering needs to be strong in our developer pipelines so that we can get the sense of urgency and direction that we need to make those real-time interventions in security in a way that's not needed for any other way we deliver. But is going to be super essential moving forward, because if we have Sbombs and streamlining of the global software security supply chain, if everybody has the metadata to inform us when we have new and known vulnerabilities, we'll be able to execute on that, and we will be able to fix as individual developer teams securities faster and easier than ever before as soon as we all start getting these Sbombs into place. So I think that's a super exciting place to be. I have been covering just a couple of ideas around SCA here. If you are interested in the entire open source supply chain, I really encourage you to check out the 2021 open source supply chain that just came out in September. We cover a whole range of things that are fascinating. Here's a couple that I hope spark your interest, no matter what your background is. But a couple of notes before I end out the talk and we can have a quick discussion. If you want, go ahead. I really encourage you, download Lift Below, give it an install. Reach out to me if you have any questions. I will be giving a Lift webinar early next month. So if you have any issues or friction, I do not expect you to. It takes about 5 minutes to upload. Go ahead and reach out to me, or go ahead and find us at Sonatype/dev signup, where we are creating a new dev zone around all of these issues of open source security, awareness, reliability, and resilience. Again, state of supply chain, but I really encourage you to also look at the vulnerability timeline. A special thanks to Stephen McGill. And if you take a picture of that code, that's going to take you directly to the dev signup. My one last note before I do finish this talk, reach out to me on Twitter if you need, but I really, really encourage every single person to look at the Sonatype vulnerability timeline and check it out every couple of weeks, because this is up to date with every single known vulnerability attack that comes in. So we are not yet to the middle of December, and we have, dozens or half a dozen new security attacks in every language every month. So if you are curious to understand and really get a picture of, when we're not just talking about supply chains and scanning and linters and analysis, what does it really look like and feel like to be doing modern open source security? This is going to show you what that means. So with that, I'm going to go ahead and stop sharing my screen, and thank you all for your attention. All right.
Well, Sal, thank you so much for your wonderful presentation. And you covered a lot of material in a very short amount of time. So that was a very packed informational session. We do have a question that came in. Todd asks, how many teams do you see that use a governance approach to adopting new libraries that include architects and security specialists before pulling in a new package into the pipeline?
Yeah, I mean, so it depends. Honestly, this is a question that depends a little bit on, what's your column, right? When we're talking about the extreme, security DevSec, not just like security for everything, right? Yeah, there was literally, I've been in spaces where before you ever put import, before I ever took anything in, there was a literal person who would go around and take on paper what I wanted to import and decide whether or not it was a security risk. Again, they were deciding on a sort of bigger level what was a security risk, but I actually think it's ineffectual at this stage to have a process where you would have, right, because let me take one step back, and maybe I am going to share my slide and sort of discuss over this micro and macro sort of idea. So this comes down to the real challenge of what development looked like 10 years ago and what the major problem is. So the major problem is this, really. It's the fact that, and I hope that's big enough, I guess you can see me as well. It's the fact that what you're asking here is this question. Really, you're asking macro architectural decision, right? I'm going to bring in this package and this package, really what we look at when I'm doing a draw.io application level structure. Making those decisions is great. And typically you'll make a reasonably optimal decision, the day you design it. But what I really wish people understood more so is the rate of decay. So for all of these applications, even if you chose the most optimal decision, right, you make the best macro architectural decision, which is what you're speaking to. In 3 months' time, some of those components will be spoiled. And they'll be spoiled for different reasons. They're going to be spoiled because everything, even if it's on a computer, is subject to the laws of entropy. So that's how you're going to be affected by site reliability engineering. Things are just going to have outages that you didn't expect. And on the other side, you might get outages or surges or problems because you actually did have a bad agent interjecting on those versions. So I think it is super important to have, security be involved in that initial decision, right? Absolutely. Don't build something stupid. Don't build something that you absolutely know is going to bleed or have like a leaky firewall. Absolutely not. But if you don't know, and if you don't have that confidence, and increasingly like a quantitative confidence that that package is going to be just as secure 6 months or a year from now, you're making a guess that's going to cost you developer hours later. And that's why I really do think that, yeah, make the best decision up front, but maintain your MTTUs. And if you can have like a dashboard that tells you like, all right, they seem to be maintaining, they seem to be getting a little bit flakier, either you can step in at that time and say, we really fundamentally need this to work. Maybe we can have some developers and provide some resourcing to this open source tool. That's really what I would hope to see happening. Or you say, great, this is a like suite or series of packages that are really stable, that have really strong MTTU scores. Let's stick with these and work with these as a sort of ecosystem collaboration. When we think about it that way, that's the way that I'm trying to think of this. And so I'm reaching out into our communities now and saying, all right, Kubernetes, Python community, all of these communities, what are our biggest open source packages? Can we be, if 90% of Kubernetes projects require this package or these 3 packages, let's make sure that those are perennially secure and that we have resourcing around those. And then when I'm making that initial architecture decision, I know for sure that's what I want. And I know that they've got equal or same MTTUs so that I'm pretty comfortable and that I'm not going to have to get one degraded and then switch to a different architecture because I've lost support. So it's a long-winded way to say it's a hard question, but it's different sport. It's continuously monitoring decay or malicious injection.
Well, Sal, that seems to be the only question that came through today. So I just wanted to give you the floor to say any kind of closing remarks or any parting words you'd like to leave our audience with.
Nothing major today. I do hope that if you enjoyed or really sparked any interest in this talk, do reach out to me and reach out to my team. Again, it's Kimmich_compute. So that's KIMMICH_compute on Twitter. I'm available anytime. I love to chat. Yeah, if I inspired anything in you, I hope that if you do not have cybersecurity in the name of your current role, I hope that you at least have it in your mental job description now, because it's part of it. If you import any packages, if you rely on open source, yeah, you're in it. And that's sort of my job. My job is to teach you that. So I hope you learned that. Reach out to me if you've got any clarifications, but I enjoyed chatting today. So thank you so much.
And thank you so much, Sal. Quick reminder to all of today's audience that the session was recorded. Following the webinar, you'll receive an email with a link to access the recording on demand. And you can also find the recording living on the DevOps website. Just visit devops.com/webinars and look in the on-demand section. You'll find it waiting for you. On to our 4 $25 Amazon gift card winners. Our first winner is Martin C. Congratulations, Martin. Our second winner is Geroid M. Congratulations. Our third winner is Fabio L. Congratulations, Fabio. And our fourth winner is Todd F. So congratulations, Todd, and our other 3 Amazon gift card winners. Sal, again, thank you so much for your time, for putting together your PowerPoint. And I'd also like to thank you, our audience, for being with us today for the entirety of the presentation. This is Cody J. Brown signing off. Have a great day, everybody.